to Kubernetes Fortnight. Today we're going to be talking about CI/CD pipelines, best practices, and principles. If you want to go to the next slide, Jeremy, yeah, we do these every 2 weeks. So we'll have information about the next one posted to our social and everything. And then, like I said, we'll post this to YouTube after the video has been edited, and it'll be on our YouTube page. But Jeremy Miller, let me go ahead and hand it off to you. If you want to go ahead and introduce yourself and let us know what you're going to be talking about today.
Yeah, hey everyone, welcome. Good morning, good afternoon, good evening. My name is Jeremy Miller, and I'm a solutions architect at Platform9 on the solutions engineering team. So I help customers as they're onboarding with the Platform9 Managed Kubernetes and OpenStack products, and I help help them solve any initial challenges, provide integrations with their infrastructure, and then get them rolling. So a little bit of brief background about myself. Over the last several years, I've had a variety of different roles in my career. I've been in a network engineering role, a site reliability engineering role, software engineer, been a DevOps team lead. So throughout all of those, I've always really enjoyed automation and release engineering and helping organizations create pipelines to get their changes out into their environment in a secure fashion. So it's my pleasure to talk to you all today about some of the best principles and practices that I've discovered along that journey. So without further ado, let's go ahead and get started. Today, what we're going to cover are some, as I mentioned, pipeline best practices and important principles for day 2 operations. This typically is going to entail working with a variety of different teams, like development teams, and enabling their application deployments. So following that, there will be a demo. I'm going to play a couple of roles. The first one will be a day in the life of an application developer using continuous delivery for deploying code changes. And then the second role will be an SRE going behind the scenes, and I'll show you how I put all of this together in the pipeline detail. So as I mentioned, day 2 challenges for PMK customers are going to typically entail implementing a process for development teams to start testing and deploying their applications into the new Kubernetes environments. You are going to want this process to be well-defined and secure for the best outcomes. So instead of granting access directly to development teams or individuals, one strategy is to quickly implement a reusable continuous integration and continuous delivery pipeline template. And it's going to have narrowly defined scoped access to handle Kubernetes deployments on your development team's behalf. Furthermore, I'm going to demonstrate how the Platform9 Managed Kubernetes console can provide all the access necessary for these dev teams to gain the insights and to have the visibility they need into their application deployment and thus accomplish their day-to-day jobs. So you're probably really familiar with the term pipeline and CI/CD, but just to level set, generally speaking, a pipeline is a set of commands that acts on a source control code commit or something like a merge request, and then performs a series of automated tests and promotions on that code change and promoting it into an environment in your organization. So specifically with regards to Kubernetes deployments, the pipeline's job is to replace the manual and loosely defined processes that are typically performed by an operator or a developer running kubectl or Helm commands, and instead utilize well-tested playbooks. So as I mentioned, there's a series of lessons that I've learned throughout my career, and I wanted to share some of those automation best practices that are crucial to keep in mind as you design your pipeline template. The first being infrastructure as code. So everything about your company that is electronic and moves or changes, that should be treated as code and should be kept in source control. This provides transparency to the organization and also to external auditors, if that's applicable. So a pipeline should be utilized to deliver this content. And we all know that manual testing and promotion of changes will inevitably result in failures. So automate as much of these tests and commands as possible with continuous integration. It is very important to manage the app code being tested and promoted alongside the Kubernetes manifests in one place in the same source control repository. Restrict kubectl write access to a very limited number of users in the pipeline, and specifically the pipeline user. Don't forget that inadvertent mistakes can happen easily by people that have potentially too much access, or also don't forget that it's not out of the question that it can be an internal bad actor that you need to protect your organization against. Don't be worried about the speed of continuous delivery. I hear a lot of people concerned about continuous delivery. It's actually a big benefit. Just because you are continually delivering application changes into a test or stage or QA environment with every code change, this does not mean that obviously you're going to deploy those same into production immediately. I'll demo how to perform those promotions here in just a bit. So some more important principles to follow as you go along, you start this journey. Any change to the application code should ideally trigger an automated bump of the application version. You're also going to want to tag the source control repository every time the application version changes. So you have atomic history of the changes that occur to that application. The change to the application code in source control should also trigger a new image build and publish that image into your organization's image repository. Following that container image build, you're going to want to additionally tag the container image with that same version that was just bumped. And what I found that works really well is semantic versioning. It's very simple but effective. It's the major.minor.patch versions. And they work in basically all the scenarios that I've encountered. And with that change set, while the repository, before the repository is tagged, one thing that was really helpful is to automate a change log entry showing the new version along with the links to commit delta from the last time the repository was tagged. So you have a running history of all the changes from version to version.
So Jeremy, with something like this, I'm probably not tagging each of my new builds as latest, right?
No, not tagging, but you're specifically tagging them with that semver version. Yep. So also, following that, your automation should then deploy the latest image into your test Kubernetes environment. Change to the Kubernetes manifest is always going to trigger a new deployment into that environment. And this is continuous delivery in practice. And I found that super important because it will help drastically shorten the feedback cycle and help by providing access and visibility of changes to the applications to downstream teams like QA teams and testers and the rest of the organization. They can start seeing those changes as they're coming through the pipeline and start getting to know what's happening with the product. So as I mentioned before, the application's Kubernetes manifest should really be kept alongside the application code in the same repository. And I find this is really important because all changes to the application and its manifest are then atomic, and they're tightly coupled. And this is key because it provides easy troubleshooting and understanding of the application version deployed with the respect to their Kubernetes associated Kubernetes resources, right? So any change to these Kubernetes manifests they should not in and of themselves trigger an image build if nothing in the application source changed, right? So only build a new container image if some application code changes. Otherwise, it's just, if just the manifest change, skip the build and go right into the deploy step for time savings. With regards to the Kubernetes manifests that are kept alongside the app code, one thing that I found is you can also kind of version them as well. So while the application code is versioned with a semver, the Kubernetes manifest could have their own tracking mechanism. And I recommend accomplishing this via a source control repository commit SHA annotation on each of the resources. This links the version of the deployed resource to the last time the file was changed in source control. And you can see this very easily when you're looking at the deployed manifests. Following validation of the code running in the test environment, there should be a pipeline step or stage to allow for selective promotion of the release, any arbitrary release into the next environment. Ideally, the definition of which app version is currently promoted to, say, production should also be stored in your source control repo for visibility and transparency. So then if you do that, then changing the deployment version in source control could actually trigger an actual promotion via the pipeline. All right, so we are about to start the demo of some of those practices and principles, and just to go through what some of the things I'm going to be demonstrating, I want to show you how you can utilize a standard commodity Jenkins CI server to create a continuous deployment pipeline. I will automatically bump the semver of the application and containers with GitHub Actions. And I chose GitHub Actions for the step because it's a small integration that does a very simple job really well. And doing it yourself, I've implemented it myself, and it's a lot harder. Also, you can run GitHub Actions locally in your own environment. You don't have to run them on GitHub's infrastructure. I'll show you how to do that. Tracking all application manifest changes with a git commit SHA resource annotation. Automate a changelog entry showing the commits since the last version bump, and one-step application promotion to production via a simple file change, a version change in a file. So all of this is stored, that I'm talking about, is stored in this GitHub repo. So you can take a look at this. It's open to the community. You can take a look at that later on and
to the chat too.
Implement it yourself. All right. So let's go ahead and get started. I'll just copy this into the chat. Okay, that's in chat now.
All right, I'll post it for you real quick to everyone.
All right. Oh, yep, thank you. Okay, so demo time. So here's the source control repo that I've been referencing. We've got a simple Node.js React front-end app. And I've got a couple of environments. I have a staging environment, and I have a production environment. Being a JSON application, we have our Node.js application, we have a package.json file that contains all of the application's dependency, including the version of the application itself. So you can see here, version in the main branch is 030, and that correlates to what's deployed out in our staging environment. If you can see this at the bottom of my screen here for this, I'm actually exposing the application version so that you can, for demonstration purposes, probably not a good practice to do that in production, but that's just so that we can see the changes happening. So we can see 030 is in staging, and 0.0.55 is in production. So we also have our Docker file in the same repo. We'll get into that later. Our Jenkins file that defines the pipeline. I'll show that later. But let's go ahead and push out a change, right? That's what we want to see. So let's go ahead and change our welcome message here. Okay. So let's check out a branch to make your change on. And I'm fixing the welcome message. I'm going to push that branch up. Okay. And we should be able to open up pull request. So this will allow your colleagues and team members to review the change. A good rule of thumb is there should always have been at least 4 eyes looking at a change and reviewing it before it gets merged. So this is assuming that someone else reviewed this. You're going to go ahead and create the pull request, merge it, and just clean up with a branch delete there. So this is now a series of steps is happening, right? So the first thing is our GitHub action is firing. And this is the GitHub action that I referenced earlier, and it goes ahead and figures out what the version is from that package.json. It bumps the version, it updates a change log, it tags the repository, and it does that all, like you saw, within a matter of like 8 or 10 seconds. So really quick, after that, our pipeline kicks off, and you can start seeing that's happening here. Well, that takes a while to build. So in the meantime, I'll go ahead and show you specifically some of the things that the version bumping did with regards to those best practices that I mentioned earlier. First one you'll see is a change log. This is all the changes that happened in the application. The larger ones are the ones that include features. This is a 0.3.1. That's the new version, and it's only had a bug fix since I just changed the welcome message. So when we look at the repo and the tags, we'll see that new one was tagged there. So now we have an atomic point in time reference to the changes that were just merged in. And that happens historically. It's cheap. It's not expensive to do this, but it's super beneficial. The other thing that happened was the version got bumped in my package.json file. And that happened all automatically via that GitHub action. The GitHub action itself is defined under .github workflows, and it's a simple YAML file. It's really lightweight. basically you can set up some paths to look for to trigger the action to fire. So anytime there's a change in my source code, Docker file, or my Nginx, and not these changes, I don't want there to be a cyclical loop that happens whenever the automation is bumping my changelog or my package.json file. And specifically, this is one bump action that it just takes a few parameters. You can toggle these as suited for your environment, but as you can see, it's really simple and easy to do this. Let's take a look at our pipeline. It's still going. We have a few more seconds, but this is the GitHub action that I've been using. You can check that out. If you're concerned about running your actions on GitHub runners, you can use this project here, nectos/act, and this allows you to run your GitHub actions locally in your own organization on your own CI/CD infrastructure. So, and test locally too. So it's really a powerful, cool tool to check out. Let's go ahead and jump into our pipeline and see what's happening. Let's take a look here. All right, so the first thing is we see that there's a couple different phases that happen here. First one is we're going to pull out the version from that package.json, and we discover that our app is now at 0.3.1. So we use that whenever we build the image and we tag it. So let's see, it looks like we're pushing up the image now, and we went ahead and did a deployment into staging. So here's our staging environment manifest being deployed. You can see that, in fact, we're doing a kubectl diff on the environment so we can see the changes. And these, I'll show you where these are kept, but we're annotating and labeling the application. And nothing happened in production, so we're not going to do anything there. But let's go ahead and take a look at staging and ensure that our change got pushed out. And indeed it did. We have the new welcome message, and the application, as you can see down here at the bottom of the screen, is upgraded to the new version, all with just one pull request and merge of that pull request. So the developer didn't have to do anything, or didn't have to have any kubectl write access into the cluster. Let's take a look at, now that we've seen that, we'll go ahead and take a look at the cluster itself from the perspective of the PMK console. And so we have our pod. You can see that if we refresh this, it was running at 0.3.0. If we update, you'll see the change now at 0.3.1. And we have our deployment. Same thing here. Notice that's just running one replica. And we also have a load balancer that is fronting the application. So all of that happened through our pipeline. And I wanted to jump into a couple of, the next step is, let's say we saw that we wanted to change the replicas from 1 to 2. Let's go ahead and make that change.
So far, developers don't have to know anything really about Kubernetes. They're just modifying code base, right? Like, in the images getting built now, this is going to modify a resource for Kubernetes. So this is like another jump to where they need to know a little bit more about Kubernetes to change the version, or?
Exactly. So yeah, they didn't, as you saw, they didn't have to know anything about Kubernetes. So they'll probably have come to you with questions about how to deploy their application. So what you can do is you can create a template for a deployment and let's say like a load balancer resource for them. And they don't really have to understand how that works or what it does. But let's say, for instance, they're about ready to do some load testing on the staging environment. And so you told them that in order to do that, to simulate more of a production load, they're going to have to increase the replica count. So that's something that they can easily do by going into their staging environment and taking a look and updating the replica count to 2. As you can see here, this is the first time I'm showing, so we'll jump into this a little bit more, but their manifest has these placeholders in here, and what the pipeline will do is it will substitute these out. These are environment variable placeholders. So as the pipeline detects the new versions get interpolated into this file and then kubectl applied. And that's how you will be able to see those changes in the labels and annotations when you're looking at the deployment and the load balancer resources. But let's go ahead and make this change. So again, another branch. All right, and we're going to say that our staging is equal to 2, and push that up. Okay. Same process as before. Just go ahead and create a quick pull request, have it reviewed by a peer, have them approve it, merge it. Now this time, because there was no application source code change, just a manifest change, the pipeline is going to run a lot faster, and it's just going to determine if there's any changes from what's out in the environment to what the manifest is saying to deploy. And if it detects a change, it's going to go ahead and apply it. So it's already done. It already did it. It skipped the build and it went into staging. It sees that there's a new commit SHA because the manifest resource changed, or the deployment resource changed. And the change was the replica count. So if we go into our deployment now and we update and the staging cluster, you'll see that indeed we have two pods now. Yep.
So with people getting into Kubernetes and setting up this kind of stuff, what's the usual like day one you see? Is developers each have their own small Kubernetes environment and they have direct access, and it's usually people who have a little bit more understanding of Kubernetes. And then as you're expanding into like more developers in your company, maybe you implement something like this where they learn just the basics of Kubernetes, like replicas and stuff. And then eventually you even maybe get to a configuration file where they're not even touching the Kubernetes manifests or resources or anything.
Yeah, I mean, that's a decent progression. Having and providing access to a Kubernetes environment to your developers is ultimately important, though. They need to understand Kubernetes concepts, and so that they can build and design a cloud native application. And the way they can do that locally is just use Kine or Minikube or something like that, and deploy locally and get a really good understanding for what Kubernetes is and how to interact with it. But then ultimately, when it comes to deploying into a staging or QA and definitely a production environments, we should have limited access there, and it should really be a pipeline with defined templates that have gone through review, so that there's a known deterministic outcome, and you don't have people willy-nilly making changes into those environments. Does that help, Mike?
Yeah, that makes sense.
Yep. All right, so let's see. So as I mentioned, we have this other cluster here, a production cluster. And we've gone through and we like what's in staging. We've tested it, we've load tested it, everything checks out. Now we want to promote that change to production. Let's go ahead and do that. Pull down the changes, make sure our local repository is up to date. And this time, instead of going into staging, we're going to go into the production. And I've got just this simple .env file that the pipeline loads that effectively dictates a couple of things. And this could dictate any number of things. But the first one is it sets an environment override. So you can see that previously our production environment was pinned at 0.0.55. Now we're going to upgrade it to 0.3.1, which correlates to the thing that we just tested in staging. And the other thing that it's setting is this other environment variable, which is our kube context name, which is production. Staging is named staging, so that we can differentiate. The pipeline can use this environment variable to differentiate which kubectl context it's going to use when it's talking to the environments. So we'll go ahead and this time, for the interest of some time saving, I'm just going to commit right to master. Typically, you won't do that, and you'll have main or master branch commits disabled except from PRs. Okay. Push that change up. Now, let's take a look at what our pipeline does. Again, no code change, nothing to build, just a promotion. And what I mean loosely, I use the term promotion loosely in the sense that, our environments the versions in them are pinned. Staging gets whatever the latest and greatest is every time. But now in production, we're pinning to a different version. And this could be a version that is greater or smaller. It's arbitrary, but you can see here. So in our production, we did a kubectl diff from the local manifests with interpolated values against what's out there running. And you can see the changes. So we're promoting up to 0.3.1. And that's all expected. That's good news. And so now if we look at our production environment, we'll see that it has the change. So pretty straightforward promotion of the application from your staging to
that seems pretty easy. I'm sure the setup's probably a little bit more difficult to get everything running, but then it's super easy for developers to get stuff running afterwards. Well, if anyone has any questions, do feel free to ask some questions if you want clarification on anything, or if you have any questions about what was done or any best practices questions.
Let me go ahead and show off something too.
There has to be questions out there.
Well, maybe Chris might have some questions for you.
I've got many questions. If there's people that think I have a question but I can't type it because it's too long, feel free to raise your hand and we can try to unmute you. We'll just do it judiciously for time. There was a lot of excellent content covered here.
And I forgot to show you all something too. So we're taking a look at the deployment, and let's show you how having those commit SHAs in the resources is important. So I'm in staging, I'm looking at my deployment, and I just right-clicked on it and I opened it in a new tab, and this is the resource. So now I see there's these annotations. The version is in there, and there's also the commit SHA. So if I go and look at that, and this is where we changed the replica, right? So if you open that, we can pinpoint the actual change back to the source control commit, and we can see that change. So this provides you a historical kind of log of and point in time reference to what's deployed in which environment, and tying it back to a source control commit. That's really super powerful.
So why is that important? And what kind of issues have you run into where that helped, like someone troubleshoot something? Maybe
Sure.
have a story or something about it?
Yeah, I mean, so like with continuous delivery, the idea of it is speed and shortening the feedback loop between what the developers are producing and the feedback that you as a member of your organization are providing back to those developers. So that ideally happens in a very shortened time frame, and the faster it happens, it's proven the more quickly you can course correct and fix issues or nail down exactly the target that you're trying to hit, right? There's a feature and there's you provide feedback. Maybe the developer understood it one way and you had a different idea. But as the point being is, as those deployments are continually occurring, it's easy without having this kind of mechanism for tracking changes in place to lose track of what's in which environment and what feature request it's tied to. So having these commit SHAs in here, you could easily have tied this back to like a JIRA request or something like that, and that will let you know. This is a chain of reference to show you why this change was being made. Does that help?
Yeah, that helps.
Let's see, let's go ahead and we'll just jump real quick into kind of how you mentioned like the overhead of putting this together. There is some overhead, but I tried to make it as simple as possible so that you could get this you could replicate this in your environment. If you wanted to follow along in your own organization, I've detailed out how to install Jenkins, and it's basically a single replica deployment into, it's a pod running in production right now. So nothing special about it. And I show you how to configure it. There it is. The process for deploying it is here, the Docker file, some YAML to configure it. And if you look at the pipeline itself, the pipeline is pretty basic. This is a templated pipeline, so you could use it for any, it's deployment or application agnostic. You just kind of copy this into for different applications, and you name your image repository, your deployment name, set up those environment variables. There's minimal number of stages here. The first stage is just pulling out the version from the package.json file, and this way we can set it up as an environment variable later and consume it. A verify stage, this will add time to your pipeline, but I have it commented out for demonstration purposes, but this is key to running your CI test. This is the CI continuous integration portion where you'd want it to run lint, to run static analysis, that kind of thing. But these should be a unit test. These should be fast running tests before you get to the build stage. If that happens, if verify runs successfully, you build it, the container, you tag it, you publish it with the version that was just determined from the bump. And then the deploy phase is simply setting up some environment variables, the code version, the config file path, which comes from a actual credential stored in Jenkins, and I show you how to do that. And then you run a deploy.sh script. It's agnostic. You pass it to the deployment name, and we can take a look at what that looks like. As I mentioned earlier, let's see, we have the manifest, just jumping to that real quick so you can see how this ties together. The manifests have these placeholders. So there, again, there's that deployment name, the GitHub SHA, we calculate the code version, and the image repo and code version. So these all get interpolated at deployment time. So there's the deployment resource, and here's the load balancer service resource, again with annotations that you saw earlier. And then finally, to tie it all together, the deploy.sh script is real simple. It takes one parameter, as you can see down here, which is the deployment name, and it goes through each of the manifest files, the YAML files in the K8s directory, and determines what their commit SHA is with this git command. Then it uses an env substitute command to interpolate the environment variables into that manifest and passes that to kubectl diff to determine if the environment even needs a change. If it does, then we go ahead, we apply the interpolated manifest, and we do a kubectl rollout restart of the deployment. If there wasn't a change, then there's no differences, and we skip doing anything, exit 0. See, I think that covers pretty much the behind the scenes of how things were put together. And as you can see, I mean, it's one bash script that's agnostic, can be reused, and a bare bones Jenkins CI server that's deployed as single replica with a host path storage mount point on one of your worker nodes in your cluster. And
that's awesome. Thank you so much for everybody answering some of the polls too. Sorry for some of the misspellings. I was trying to type them out real quick so we can get some information to see what you're interested in. It looks like you finished off the demo there, Jeremy. We'll see if, does anyone else have any questions or anything, or want to ask Jeremy anything before we start wrapping up? Or Jeremy, do you have anything else you want to say, or Chris, you got any wise words to add to the end?
I've always got stuff to say. It's probably one of my negative traits. Don't stop talking. I'd love to sort of show off some of the stuff that we're working on. It's going to come out in March that should hopefully simplify a whole stack of some of the continuous delivery piece, and importantly, sort of really enhancing that developer or even sort of DevOps person that's running apps on Kubernetes. What do we think?
I think we'll have you said we might do a Fortnight here, maybe a month from now, or?
I can show some stuff now if we're feeling brave.
If you want to. I mean, so this also goes along with some of the CI/CD stuff. If you want to stop sharing, Jeremy, and Chris can go ahead.
Let me let's make sure I'm on.
Thank you so much, Jeremy. A lot of that was so useful. Sorry.
So Jeremy delivered a very timely Fortnight session that's sort of talking about setting up CI/CD on a Kubernetes cluster that you can use for yourself. We sort of see continuous delivery as like the next evolution of running cloud native and Kubernetes, and that they really should be done well and together. And we really want to make that simple for people. So we've been working hard on bringing in Argo CD as something that Platform 9 is going to run as a SaaS platform. Hence the question. And I'm gonna share my screen. Please do let me know if it does not work. Can you guys see everything fine?
Yeah, looks good.
And we've also made some changes to our platform as well. So this is a UI that will be coming out in about a month to all of our users, free tier, growth, and enterprise. Introducing a new app switcher here to bring in a little bit more flexibility in using the product. And you can see here that Argo CD is being listed there. And what we're doing is we're running that as part of the SaaS platform, automatically connecting any cluster that's running, and then allowing you to use Argo CD's continuous deployment as a product to deploy apps and services into the cluster. What does that look like? This is Argo CD running. These are both dev builds, exactly the same endpoint here, right? I want Argo CD UI.platform9. This one here, exactly the same. Argo CD UI platform9. So the same instance, same username and password that I logged into, my platform9 instance here is the same one I used to log into Argo CD. And you can see here, I've deployed the well-used test guestbook app onto a cluster, and that's all live and running. This cluster is actually not a cluster that's in my platform9 instance that I was just showing. It's actually a cluster that's running in a different platform9 instance, and I used the Argo CLI to connect it, provide authentication and the service account, and then deploy this app. So Argo CD deploying into a cluster that for all effective purposes could be any Kubernetes cluster. As I said, we will auto attach any cluster that we're managing. So if you're running, EKS, AKS, GKE, and you want to try it out, you can just come in here, click import cluster, attach it. You'll see this come in on the imported clusters list, and then you can start using Argo CD without having to do anything at all. All secure, all running over the outbound communication from your cluster. And then when your apps are up and running, we've brought in a lot more depth into our workload views. So you can start exploring things like jobs and cron jobs that are going on, stateful sets that are running in your system. And importantly, being able to drill in and see the details about these configurations and these workloads that are running. So looking at a stateful set, what pods are related to it, are there any events impacting it, what logs are there from the pods that are running into it. And if you're brave, like I like to do sometimes, come in and start modifying this YAML to try to quickly troubleshoot things. Click save and it's going to go update it live. Of course, this is reliant on your user having the right role-based access controls in the cluster. So do keep that in mind. If you're an administrator, you can give people a read-only view into this as well, so they can consume the data and not come in and augment things. So stay tuned. This is going to be going live to the world in March, and I think we should really do a refresh of this session in sort of consuming all of it as a service from platform9 and using Argo CD to do the continuous deployment piece into your applications and infrastructure. So I'm pretty
awesome. Thanks for the preview
coming out. Yeah, this is exciting stuff that we're bringing in.
All right. Thank you so much for everybody for joining. Thank you for the presentation, Jeremy. It was great.